All right, ambiguous case. So law of signs, same formulas, using the same way, but something weird is going on when we have the ambiguous case. We talked yesterday about side, 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 angle, side, all that stuff. So, at the risk of putting this out there for the world to see, it's fair to say that the ambiguous case is a pain in the angle, side, side. So if angle, side, side is the information you have, then it's going to be ambiguous case, and you're going to have to really be careful. Let's back up a little bit and get to the root of the problem here. The basic issue comes from this. If the sine of angle A is 1/2, all right, unit circle experts, if the sine of A is 1/2, think about the unit circle. What angle might that happen in? Pi over 6. What is that in degrees, since we've been doing degrees? So yes, it is pi over 6. What's that? 30. But is there another angle whose sine is 1/2? 5 pi over 6. And in terms of degrees, that would be the 180 minus 30, or 150. So when we use the calculator to go backwards, when we use the calculator to find an angle, there's really two answers. You remember when we did this a couple units back, the calculator would give you one and you'd have to do pi minus to get to the other. Does that sound familiar? I hope so. Well, today instead of pi minus to get the other, we're going to have to do 180 minus to get the other. And that's part of what makes it ambiguous, is there might be two angles. So we'll use law of sines to find an angle, and that's the problem. When you hit inverse sine of something, your calculator tells you one answer, but you have to know there's another answer. The hidden answer, the one your calculator can't tell you. 180 minus whatever the calculator says. 180 minus the first answer. I don't know how else to phrase that. So we've dealt with this issue before. When you do inverse sine, you've got to remember that there's really two answers there. Your calculator can only give you one. It's a little bit like hitting the square root button on the calculator. Square root of 9 is 3, but negative 3 is sort of an answer. It's kind of the same thing here. All right, so there could be two triangles, and I guess that's part of what makes it ambiguous. Ambiguous means unclear, or having more than one meaning. It's not just that there are two triangles, it's that there might be two triangles. So here's the cases. You can get two triangles. That would happen if both of those angles work, and we'll see what that means in a minute. So you get two answers. If they both sort of work out, then that means you got two triangles, two solutions. It can work out where only one triangle works. So only one of those angles works. And it can even happen that there's no triangles. That's really our favorite case because there's really nothing to do. And you discover that early on that there aren't any triangles, and so you're just done with the problem. So you like these because they're not much work. That happens if you get the sine of A equals something greater than 1. Right? The sine is always between -1 and 1. You don't have to remember that because when you type it into the calculator, inverse sine 1.35 doesn't work. So the good news is you don't have to know ahead of time which case you have. Just work the problem like normal, and the cases will take care of themselves. So it's not like you have to memorize, well, what leads to this, but what leads to that, what leads to this other one. Just work the problem like normal. Remember, that's the key thing, and the cases will take care of themselves. So books usually present this like you got to memorize and understand all the things that are happening to make this. Forget that. Just work the problem assuming there's two triangles, and as stuff happens, you'll figure out if there's not. Show you what I mean. Example 1. A equals 6. B equals 7. Angle A equals 65 degrees. I'm going to draw the triangle, although, again, not absolutely necessary, because you got A information, so you could start with that. You could jump right into a formula, but I like to put it on the picture, so. Let's see, this is an angle side-side problem. Angle side-side. Yeah, it's kind of tricky to say angle side-side and then write SSA. But years of teaching math has given me the ability to pull that off. What words you use in your own notes is up to you. So if you think that's funny and you're being super rebellious, knock yourself out. No one will care. But as for me, I'm going to stick with SSA for angle side-side. So that's my hint that something weird is going on with this triangle. Oh, by the way, back up just a second. In geometry, in proofs, you weren't allowed to use angle side-side, and you just remembered it because, oh, that's the bad word, we can't use that one. But the real reason was there could be two triangles with the same angle side-side. So you can't use that to prove they're congruent because it doesn't work, because there could be two triangles. So now, rather than just saying, well, don't use it, now we're going to explore what the two triangles might be. Right. Anytime you've got information across from each other, you know you can use law of sines. So sine 65 over 6 equals, don't have much choice on this one, I'll have to use the B stuff. Sine of B over 7. So sine of B equals 7 sine 65 over 6. And I'm solving for an angle, so I'll have to be careful here. This is where I might get two answers. So there's 7 sine 65 of 6 over 6. What do I do next? Inverse sine to figure out the angle that gives me that sine. So inverse sine of 1.057 whatever. And I get some sort of error. And the reason is there's no angle whose sine is bigger than 1. So this did not work. There is no angle B that works for this. That means there's no triangle. And so that's our answer. Just no triangle. Now, maybe that seems weird because you're like, well, we just drew the triangle right there. What do you mean no triangle? if we drew it to scale, so I'll try to draw it roughly to scale. That's 65. We're going to say that's 7. I don't really know how long this side is over here. We weren't given that. And I don't really know this angle, but I do know that this side length was 6. And so it's too short. It doesn't reach the other side. So that's why there's no triangle. So we drew a picture, but our picture wasn't quite right, because if we'd have been more careful, it doesn't work. So that's one of the cases for ambiguous case. Again, you don't have to know it ahead of time. You just start working the problem, and if something blows up, it's like, well, that didn't work. No triangles. Yeah, so how do you know? When you do inverse sine of something bigger than 1, it says error domain. So you need to know that that means that doesn't work. There is no angle who will work for that. So you're done with that problem. That's why we like that case, because it happens early, or the error happens early, and you're done. You move on to the next one. Example 2. Angle C equals 37 degrees. C equals 12. And A equals 5. Again, I'm going to draw the picture, but you see the C and C, so you could set this up without a picture. I just don't like that. So ABC, C is 37, side C is 12, side A is 5. So again, it's a angle side problem. So I just need to be cautious. It doesn't mean something's not going to work. It doesn't mean something weird happens. It just means be careful. So sine of 37 over 12 equals sine of A over 5. Move the 5 over. Five sine 37 divided by 12. What do I do with that answer? That's what the sine of A equals. So inverse sine, to go backwards to figure out what A is. So inverse sine of that will tell me what angle A is. 14.522. But that's what my calculator told me angle A is. But angle A could also be something else. So it's like I've got an angle A1 possible and an angle A2 possible. So how do I figure out the other? What's the other angle? Subtract it from 180. So angle 2 is 180 minus the first one. 65.478. So now this looks like we're going to have two separate problems, or two separate triangles. One where angle A is 14 and one where angle A is 165. So let's work the one with angle A and see what happens. So angle B, well, the one with angle A1, and then we'll go and do angle A2. How can I find angle B? Subtract from 180. 180 minus 37 minus 14.522. Because I've separated these into two separate cases now. So I'm going to work one case, figure it all out, and then I'll go work the other case. So angle B is 128.478. And now the only thing I'm missing is side B. So sine of 128.478 over side B equals, I can use A or C, it doesn't matter, but C was the original information, so I should probably use the C stuff. Sine 37 over 12. So cross multiply. Again, some of you aren't going to show this step because we've done it enough. Whoops. Made the mistake that happens. Confused my B's for 6's there. So 12 sine 128.478 divided by sine of 37. Tell me what side B is. 15.610. So now I know everything for the first option. If angle A is 14.5, I found everything. And then this is the bad part of ambiguous case. It's like there's two problems in one here, because now I got to go solve the other side of this problem. If angle A2 is, or if angle A is 165, maybe even a separate triangle would be helpful. I'm going to be filling in for information now. All right, how do I find angle B? If I know these two, subtract from 180. So 180 minus 37 minus 165.478. That's the appropriate face I just saw. It's like, wait a minute, I can't have a triangle with a negative angle in it. What in the world is that about? Well, that means that doesn't work, which means that other angle didn't really work. So this was the one triangle case. You have to, if it's a two triangle case, you just got to work the separate, and you end up with sort of two sets of answers, which is what's going to happen in the next example. It is long. It is a pain. But the point of doing them is not to, again, books and videos online like show you ways to figure out which case it is. You don't really need to do that. Just work the problem, and it either happens that it doesn't work, or you get one triangle but the other one doesn't work. There's one more case we haven't done, so you can guess what's going to happen in this example. We're just going to get two triangles that do work. So this is our least favorite case right here because it's the most work. Well, probably not many since it takes a while and there's so many other things we have to do. A equals 7.5, B equals 12, angle A equals 35. Again, if you want to try to do this without a picture, I think it's possible, right? Because you got A and A, so that'll be we already see this is going to be a law of science problem. But something about the picture helps me out. Again, it's angle side side, but you don't really even need to note that. Like, just start working it like a law of science problem. Sine 35 over 7.5 equals sine of B over 12. Here is where I would recognize that, wait a minute, this is a potential issue. Anytime you're doing inverse sine, there's two possible answers, and that what may lead to two possible triangles. So this is where I recognize that there could be a problem. I don't usually look and say, oh, it's angle side side, therefore ambiguous case. I just work the problem and know that if I have to do inverse sine, then I better be real careful. Sine 35 divided by 7.5, but then inverse sine of that sine 35 divided by 7.5, inverse sine of my answer. The calculator can only give me one answer. How do I get the other answer? What's the other possibility? Subtract it from 180. So angle B1 is that one. If I subtract it from 180, kind of did that the cheating way there. The other possibility is 113.405. So here we go. We're going to start down the path toward two triangles again. And last time it didn't work. This time, I mean, we don't know ahead of time it's going to work, except that, of course, the teacher's going to do an example of one of each. So let's see. What could we find next? Oh, angle C would be 180 minus the two that we have. 180 minus 35 minus 66.595. 78.405. And so the only thing left now is side C. So sine of 78.405 divided by side C equals, I know almost everything now, but I should use the original information. So back to that A stuff, sine 35 over 7.5. Some of you are going to jump straight to the calculator, which is okay as long as you know what you're doing. Others of you are going to show one extra step in here to make sure you don't mess it up. Others of you are going to show even one more step to get C by itself. I'm not going to because I think we're okay from here. So C is 12.809, side C. So there's option 1 for that triangle. Now on to option 2. I guess the good news is it's the same exact steps with just different numbers. So whatever we did for triangle 1, we're going to do for triangle 2. So 180 minus the other two angles. And this is the spot where we figure out if this second triangle works or not. If we get an angle that makes sense, then it works. If we get a negative angle, then something's not right. That works, 31.595. And so sine of 31.595 over C equals, all the way back to the original, sine of 35 over 7.5. So again, it's the same process with different numbers. Cross multiply. I'm going to be lazy and not show my work. 7.5 sine of 31.595 divided by sine of 35. I do want you to show the setup so I know where you're getting your numbers from. But if you can solve it from there without showing steps, that's okay. But don't try to be a hero. If you need to write it out, write it out. So there were two triangles that worked for this particular problem. Let me see if I can sketch it to show you that. So you don't need to draw this, but I'm going to try to sketch what just happened. So angle of 35 is pretty shallow. This side was 12. And we don't know how long this side was, so just a dashed line. This side over here was 7.5. So it could be 7.5 that way, or it could be 7.5 that way. So that's your two triangles. You got one triangle like that, and you got one triangle like that. That still fit the same angle side. And so all the way back to geometry, why you couldn't use that is because angle side might have two different triangles with the same angle side. All right, the assignment today is worksheet 2. Answers are posted in Schoology. They're also up here for you guys in class right now. This is definitely one that you want to try. I know you're thinking it's Friday, it's weekend, I'll just get this later. These are tricky, so please try these. Don't let this one go. I'll call some people out that usually let them go, but I won't do that. I should. But they know who they are. If you don't practice this one, you're going to miss it. Like, I don't know how else to say it. And some of you, you're going to opt for that route. And I don't know why you're going to opt for that route. But that's the route that some of you take. Don't do that. Try this one. You've got to try these because they're ambiguous. They're weird. And so you need some practice on them. Again, answers are on Schoology for when you want to check.